we should all celebrate because today we can finally talk about a really exciting release that has nothing to do with AI, layoffs, or the death of the software job in the next 6 to 12 months. This is Evan Yu, and these days he is almost single-handedly pushing web development forward. He first built Vue as an alternative to Angular, and then he came up with Vite as a response to the painfully slow, increasingly bloated tooling that made starting a front-end project so difficult and energy-draining that people spent years complaining about it. It's funny how we are looking at that JavaScript fatigue period as the good old days, now that every conversation in tech is about whether your next colleague will be a coding agent or whether you'll be the one watching plumbing tutorials at 2 a.m. But I digress, so today let's focus on the good news instead. Evan's company, Vite has now released Rolldown 1.0. Rolldown is a Rust-based JavaScript bundler built specifically with Vite in mind, so Rolldown is now stable, production-ready, and already powering Vite 8. The important part about the 1.0 release is API stability. Rolldown now follows semantic versioning for its public API, with option names, option types, and plugin hook signatures expected to remain backward compatible. Note, however, that while Rolldown's API is stable, its output behavior can still improve. That means Vite may continue changing things like dead code elimination, chunking, inlining heuristics, and optimization defaults. However, those changes are supposed to improve the generated bundle, not change how your application behaves at runtime. So the promise is that your configuration will remain compatible, your application will behave the same, but future versions may generate smaller or faster outputs. But to understand why Rolldown exists, we need to look at how Vite worked before this. After all, the inner workings of a bundler might seem too technical for your day-to-day use case, but the implementation details of these tools usually have a huge impact on your own applications. Vite originally used a two-bundler architecture. During development, it relied heavily on ESBuild because ESBuild was extremely fast. For production builds, it used Rollup because Rollup had better output control and a mature plugin ecosystem. When Vite first appeared, JavaScript tooling was still dominated by slow startup times, heavy configuration, and development servers that made simple projects feel heavier than they needed to be. Vite gained immediate popularity, thanks in part to the speed it offered, thanks to using ESM during development and avoiding bundling the entire app up front. On production, Rollup was already respected for its tree-shaking, output quality, and plugin model. So Vite combined fast development with strong production builds. But over time, this architecture also created problems. Using ESBuild in development and Rollup in production meant Vite had two transformation pipelines, two different bundling models, and it had to bridge two different plugin systems. Every time the ecosystem became more complex, Vite needed more internal glue code to keep the experience consistent. On top of that, when a tool has one system for development and another system for production, subtle differences can appear. Rolldown was created to simplify this architecture. In other words, Evan Yu and his team wanted to take away the usual "it works on my machine" excuse. The goal was to give Vite one bundler that could eventually serve both development and production use cases. It needed to be fast enough to compete with ESBuild, compatible enough to preserve the Rollup-based plugin ecosystem, and flexible enough to support the features Vite needs in large real-world applications. What's really important is that Rolldown was designed as a drop-in replacement for the Rollup API. This means the transition to Vite 8 will be smooth for most use cases. Rolldown is written in Rust and uses Oxidation compiler for language-related work such as parsing and minification. As a quick side note, Oxidation compiler is part of the broader Vite effort to build faster JavaScript tooling infrastructure in Rust. If you think having all these tools in place is overkill, remember that speed really matters because bundling is actually a complex process with a lot of intermediate steps. A bundler has to parse source files, resolve imports, apply transformations, run plugins, analyze exports, remove unused code, generate chunks, and write output. In large projects, these steps add up quickly. According to Vite, Rolldown is around 10 to 30 times faster than Rollup, with the difference becoming more visible as project size grows. As you all know, when builds are slow, we usually avoid running them, and I think I'm not the only one who had to fix a production build because I skipped the process locally. On the other hand, when builds are really quick, the feedback loop is much tighter. But perhaps the most exciting part of this 1.0 release is the upcoming full bundle mode. Since its inception, Vite's unbundled approach was the gold standard, but as projects grew to thousands of modules, network overhead in the browser started to become a real problem. And Rolldown is fast enough, Vite 8 can now experiment with bundling your entire app during development in milliseconds. Early benchmarks are showing a 3 times faster dev server startup and a 10 times reduction in network requests. Under the hood, Rolldown is the middle layer of the new Void Zero Trinity. It sits between Vite, which is the orchestrator, and the oxidation compiler. While Rolldown handles the linking and packaging, oxidation handles the heavy lifting of parsing and transforming. This architecture allows for raw AST transfer, meaning the tools can share the structure of your code in memory without constantly reparsing it, which is exactly why we're seeing these 30x performance leaps. And this is where the awesome trivia for the day comes in. A 30x performance leap is very rare in any industry, but one instance I find really fascinating is that sometimes you get magnitudes faster by being able to stop better. This is what happened in Le Mans back in 1953. Up to that point, every team in the field was running drum brakes, which were getting the job done, but they had a fatal flaw. If you pushed them hard enough, they'd overheat, fade, and basically stop working. As a result, drivers had to start braking absurdly early just to make it through a corner alive. Then, the Jaguar C-Type rolls in with disc brakes, and the entire dynamic of the race changes. The Jaguar weren't the fastest in a straight line, but they could stay at full throttle longer and turn in later than physics had previously allowed for anyone else on the track. And, if you are wondering why we have a Le Mans reference in a tech video, remember that the creator of Ruby on Rails and the Marquis is a Le Mans winner. If you like this video, you should consider joining our community, where I'm posting more dedicated weekly content. Please don't forget to smash all the buttons, and until next time, thank you for watching.